So as I mentioned, vectors are mathematical objects with direction and a magnitude. What we can do, we can take two objects and add them together. We can also find the difference between them. So vector addition. Suppose you have two vectors. Vector u, which is, for example, denoted by x1, y1, and vector v, which is denoted by x2, y2. It has different components. We can add these two vectors together, u plus v. This guy gives you a new vector, x1 plus x2 and y1 plus y2, which is basically the same as writing it as x2 plus x1 and y2 plus y1, which is basically saying that, hey, u plus v is the same as v plus u. So the addition between vectors is commutative. Let's take a look at one example together. In this example, I give you the following simple vectors. Vector u is given to you as -1 and 2, and vector v is given to you as 2 and 3. I want to find the sum or addition between these two vectors. I'm creating a new vector. The new vector is u plus v, which is -1 plus 2, 1, and 2 plus 3, which is 5. New object by adding these two vectors. How do I visualize this? Oh, take a look. I have my x-axis, I have my y-axis, all right? So -1 and 2. -1 and then 2 units up. The starting point, the initial point for any vector, if it's not given, it's at the origin. So at the origin, we stop at this point. This is vector u. Now for vector v, 2 and 3. 1, 2, and 3 units up. This is your vector v. When I add them together, I give a different vector, which is 1 and 5. 1 and 5 units. This is the sum of these two vectors. U plus v. Take a look. If I form a parallelogram using these two vectors, my scaling wasn't very good, but you see what's happening here. This parallelogram gives me the sum of these two vectors, u plus v, which is denoted by 1 and 5. So we usually use this symbol to represent vectors, or in some books they use parentheses, but they make sure to specify that we have vectors.